Okay, now that we have a good start to our level, it's time to create our own grass so that we can paint it onto our terrain using CryEngine's Vegetation tool. We're going to actually model out the blades of grass in 3ds Max so that we can create a diffuse, normal map, and alpha mask texture. The first thing we want to do is find a reference image so that we can make informed decisions rather than just coming up with some generic grass from our imagination. I think this is a really nice wild mountain grass, and it's going to fit the demo level I've already started nicely. Initially, grass might not seem like a high priority asset, but when you think about how often it'll be used and the portion of the screen that it covers, it makes sense to treat it with the same importance you would a character or piece of architecture. In general, you should put effort into an asset proportionate to how often it's going to be reused. Okay, let's jump into 3ds Max and create a plane in the front view. We'll try and make it roughly the same proportions as our reference image, and then you can just drag the JPEG from your desktop onto the plane. I also want to move it back slightly so that when I create new geometry, it'll show up in front of the reference. Now I'm going to switch to my top view and go to the Standard Primitives tab and choose Cylinder. This will be our first blade of grass, so we should change it to a 4-sided cylinder here so that we have a nice diamond-like cross-section. I'm going to use the Scale tool to adjust its proportions, and I'll change it to 4 height segments so that we can get an edge loop directly in the middle. Next, I'll scale it down on the y-axis so that it looks more like a blade of grass. I'll also convert it to editable poly so that I can jump into vertex subobject mode. Next, I'll just scale the other segments so that we get a nice natural taper, and collapse the top vertices to a point. Okay, this will work for now, so let's press M to bring up our material editor. Navigate to the Maps dropdown, expand it, and select the None box next to Diffuse Color. Next, go to Maps, select Gradient, and turn on the Show Map in Viewport here. Then press Apply to Selected button. The gradient material should show up on your grass blade, and we can see that the gradient colors are applied from top to bottom. Now we can select the color boxes and then sample directly from our reference image. Once I sample a few different colors, I'll copy the material over twice and I'll make slight variations to their colors. I'll also shift drag my model over and make 2 more copies, then apply the material variants to each copy. Now we should have 3 different blades of grass, each with their own material, before moving on. Alright, I'll move these off to the side so that we can always have these original blades intact. From here, I'll shift drag a copy over, and I'll use an FFD 3x3x3 to twist and bend it. Remember to right click and choose control points when using an FFD, otherwise you won't be able to manipulate the lattice points. I'll continue to do this with each different blade so that we have a nice variety of color and shape. Once I have a decent cluster, I can select them, mirror them, so that we don't have any blades that repeat exactly the same. Just remember to really trust your reference at this stage, and also try to avoid having any blades that look drastically different, because once you duplicate those clusters 1,000 times in your level, anomalies will really become noticeable. Here's an example of an older grass that repeated way too often. Another common issue I see is students making their grass too dense. Since this will eventually become a flat, transparent texture, the more dense you make the grass, the more noticeable the geometry plane will be. After doing this demo many times in class, I would recommend a density and width close to this, but if you like to live dangerously, then you should try your own density. Just be careful that you don't make the grass clump too small in length, because then you'll have to paint much more of those clumps to get a nice dense patch of grass. Okay, this grass is ready to bake, but I also want to add a mountain flower like the one seen in this reference image. Now, as with most things, there are plenty of ways you can model this and have equally good results, but for this I'm going to start with a cylinder that is equal in size to the amount of petals the flower has. In this case, 10. I'll then convert to Edit Poly, delete everything but the front surface, and then use the Inset tool, followed by Collapse to quickly divide the surface into wedges. Now I'll delete all but one edge so that I can make edits, and I'll add the subdivisions I'll need for shaping it. Once I have the general shape of the petal, I'll go into my front view, set my angle snap increments to 36 because 360 degrees of rotation divided by 10 petals equals 36. Now I'll shift rotate one petal, and in my clone options window, I'll choose instance so that all the petals update when I make modeling changes. They all become living clones of each other. I'll also choose 9 here under the number of copies so that it fills in the flower completely. Now I can go back and edit any one of these petals and they should all update together. And then I'll add a shell modifier to give it some thickness. Now I can still go back to our editable poly in the modifier stack and adjust the form of the petal. If we want to see the end result with the shell on, we can toggle this Show End Result button here. Next I'm going to add a subdivision down the center so that I can add a groove. By having our instances set up ahead of time, we're able to see the entire form update as we make changes. Now, I tried achieving the same flower color by using gradients like we did with the grass, but I didn't have very much control over the color blending. So instead, I created a quick diffuse texture in Photoshop and saved it as a TGA. Now I can create a material, load the diffuse, and apply it to the petal. I'm going to delete the shell and add it again later after I assign UV coordinates. I'll add an unwrap UV modifier, and I'll select all polygons and use a quick planar map to assign new UV coordinates. And I'll apply the shell back on, followed by a turbo smooth at the end. The turbo smooth subdivides the same way as the NURMS toggle, but by adding it on the modifier stack, I can make sure it smooths after the shell. If I had used the NURMS smooth before the shell, the hard edges would remain, as you can see here. Alright, this should work fine. Now I'll create a square plane by holding Control, and I'll position it so that it's just behind the grass geometry. We'll transfer the color and normal information from our high poly objects to this flat plane, so the layout of these objects determine where they reside on the final textures. You can move things around later in Photoshop, but we'll start positioning the grass in the top right corner and the flower over here on the left edge. I'll also create a stem for the flower, but I'll separate it slightly because I'll want to assemble multiple flower tops and stems for variety. To create the stem, I can go to the Shapes tab, choose Line, and I'll click and drag out each point so that it has a nice subtle bend like this. Next, I'll check the Enable and Viewport box here and adjust the thickness under Radial Options. I'll also reuse the grass material to get a quick color fade. Once I'm happy with the shape and thickness of the stem, I'll convert it to editable poly so that it becomes regular geometry rather than a spline. I'll also copy one of the blades of grass over to use it to make some of these stem nodes. Now I just realized I should add some reinforcing edges on the blades of grass so that we can smooth the geometry while retaining the crisp edge down the center of each blade. Ideally, I should have done this to the original blade of grass, but I forgot. I'm very sorry. First, I'll select all the grass blades, and then I'll right-click and choose Hide Unselected so that we can isolate the grass. Next, I'll select one of the blades and bring up the Attach List window. Since we hid everything else, we can just hit Ctrl-A to select all and then click Attach. Go ahead and say OK to the Match Material IDs option. Now we can go into Edge mode and select one vertical edge per blade. Once you have them all selected, press Alt-R to do a ring selection and then Alt-L to extend the ring selection vertically so that we have all the vertical edges selected and none of the horizontal. Now we can go into the Extrude Settings window and zero out the height so that when we increase the extrude edge amount, it creates supporting edges on each side of our selection. When doing this with such a small amount, I would usually recommend going down to 0 and working your way back up to avoid geometry overlap. Now we can turn on the NURMS subdivision and we can get a nice crisp edge in the center as it subdivides. If yours is too soft, try going back and using a smaller extrude amount. Okay, we'll add more to this sheet later in the tutorial, but let's bake the textures out and see how they look. Select the plane and name it Low Poly so that we know this geometry is what we bake down to. Okay, now we're ready to bake our textures. Let's unhide everything and select only your Low Poly bake plane and your High Poly geometry. Right-click again and hide unselected, and then select the Low Poly plane. Let's adjust our length and width segments to 1 so that our render cage will be nice and flat. Next, go to the rendering menu and choose Render to Texture. Now this menu might scare you at first, but really there's only 3 or 4 things we need to adjust. The first thing we need to do is check Enable under Projection Mapping and then click Pick button here to select all of our high poly meshes that we'd like to render to the plane. Since we hid everything else, we can add everything in this list using Ctrl-A again and then clicking Add. You should see a blue projection plane appear above your low poly plane. If you don't see it, just click over to the Modify tab and it should pop up. Everything in between this plane and the low poly plane will get rendered to the texture. Refer to our texture baking tutorial for a more in-depth look at adjusting the cage. Next, let's open up the options panel here and choose the Setup button next to Global Super Sample and enable Global Super Sample here. This adds an extra anti-aliasing pass to the render, resulting in a higher quality texture. Let's also change our ray mist color to a darker green so that our background texture isn't red. Next, let's reduce padding to 0. Padding extends the pixel edges around the silhouette, so if you set padding to 5, it'll be 5 pixel bleed around your grass. This can be useful for other purposes, but we want our transparency mask as clean and precise as possible, so that's why we need to zero this out. Now we can scroll down and click this Add button to start defining which textures we'd like to output. First, let's choose Diffuse Map, which will render all the color information from our high poly meshes. This means that the colors we assign via the gradient maps and the diffuse flower texture will get baked down to a new diffuse texture. Let's choose 2048 so that we have a nice high quality source that we can shrink down later. Next, let's name the texture and assign the directory. I'll save these as targas and choose 32 bits per pixel so that it stores our transparency or alpha mask in the alpha channel. By default, Max will create an alpha mask for anything you render, so areas where the projector doesn't find any geometry, those will be transparent in the alpha channel. This becomes one of the key benefits of this method since the transparency mask plays a large role in successful foliage material. Those of you who have spent 10 hours selecting individual pine needles in Photoshop probably know what I'm saying. Now let's click Add again and choose Normals Map. Choose 2048 here as well, and make sure you name it and set it in the same directory as the diffuse. Now we can actually click Render at the bottom and then Continue. The render you see here doesn't necessarily represent the texture, so open up the files after to make sure it's saved correctly. These all look fine, so I'm going to copy the normal map into my diffuse texture and save this as a PSD. I'll create a new folder called Grass Demo within my ground cover directory and save it as Grass Working. Now, with the normal map layer visible, I'll save as again within the same directory. I'll choose CryTiff and name it as Grass Normal. When the CryTiff plugin pops up, choose Normal Map Low Quality under the preset dropdown and say OK. Next, I'm going to copy the normal map into the clipboard and open up Crazy Bump. I'll choose Paste Normal from Clipboard, and then I'll also go into the Diffuse tab and then choose the Copy Diffuse to Clipboard option. Next, I'll paste this in my working file and I'll set its layer mode to multiply and drop down its opacity to blend it with the color that we get from Max. This is a nice way to get a little more definition on our diffuse without it being too noisy. Okay, that looks pretty good, but before we save it, double check that your alpha channel contains the black and white transparency mask. If yours doesn't, you might have to re-render the diffuse and make sure to save it as a 32-bit targa. Now I'm going to save this as a CryTiff and choose the diffuse with alpha test preset. Alpha test is used for transparency and can only be on or off. You would use this for things like plants, chain link fences, gratings, distant ropes and chains, etc. You wouldn't use this for semi-transparent materials like glass, ice, effects, and so on. Okay, now that we have our textures, let's switch back to Max and save our scene as Baker so that we can come back anytime we want and rebake textures if needed. I'll save it in the same directory as the textures so that the folder contains all dependencies. I've noticed students can get a little carried away with how many working files and different directories they use, and that can be problematic with CryEngine and troubleshooting. When in doubt, just save it somewhere within the game SDK directory. Now we're ready to actually create our grass and export it. I'm going to reset my scene and then create a square 1x1 plane in my front viewport. Next, I'll bring up the material editor, and with a fresh material ball, I'll change the shader from Blend to Crytex shader, and then open up my maps and load the diffuse grass CryTiff into the diffuse color slot. Now, we don't need to build our entire material here since we'll be doing that in CryEngine, but we will want to see our transparency. To hook that up in Max, just drag this TIFF down to the opacity slot and change monochannel output to alpha, then check Apply under this cropping placement. Next, go to Parent, turn on the Show Map and Viewport button, and apply the material. Your texture should show up and the transparency should be working. If it's not showing up, try applying an Unwrap UVW modifier to the plane. Just adding it should make the texture update. Now we can use this plane and section off our grass using the Swift Loop tool. I'll select the grass polygon and detach it, and I'll also detach the flower and delete the other unused polys from the plane. For the flower geometry, we can rotate a copy of the stem so that it will appear from multiple view angles. Next, I'll rotate the top and use the Cut tool to create a single middle vertex that connects to the four corners. Then I'll lower the middle slightly so that we get a nice low poly flower. Now, before moving forward, we should create a scale guide in our scene that's roughly 180 units tall so that we can scale our grass to the right size. 180 units is 180 centimeters in CryEngine, and that's roughly a 6-foot size man or woman. This grass is going to be wild mountain grass, so I'm going to make it in between knee and waist high. Now remember to reset the X-form over on our Utilities tab after changing an object's scale or rotation so that its new position and size export correctly. Now we can create a larger patch of grass consisting of multiple smaller clumps. With grass, one of the trickiest problems is to make it look good from a top-down view. So I'm going to rotate it slightly, duplicate it, and rotate it in the other direction. Then when we move the two close together, the top view hides the straight geometry planes a bit better. Now I'll attach the two crisscrossing planes and start propagating them around to fill out this patch. I'm trying to get as much angle variety as possible at this stage, and I'll also start scaling individual clumps along the z-axis for more height variety. Okay, now it's time to test this in CryEngine. Remember, we always want to test things in Engine as soon as possible, so spending time guessing how this might look would be wasted. Let's make sure our max file is saved in our new grass directory. This is especially important since our geometry or CGF file exports in the directory the max file resides. Now let's go over to the Utilities tab and open up the CryEngine exporter. I originally had all my grass linked to a dummy helper, like this, but I later realized that the performance is much better if the grass is attached as one object. So take a second and attach all the grass geometry together and name it something descriptive. Then let's add our geometry to the geometry export list by selecting our object and clicking the Add Selected button. We also want to check Export File Per Node here so that we get a unique CGF for each item in the export list. I'll add my regular grass clump and then I'll copy it over to the side, add some flowers, and add this to the export list as grass demo clumps flower. Next, we want to generate our material or MTL file so that the max material and CryEngine material stay in sync with each other. To do this, name your max material something you'll remember, like grass demo, and then click the Create Material button over here. If you already have CryEngine open in the background, the Material Editor's Save dialog will pop up. Otherwise, you'll need to load the Material Editor and then press Create Material again. Once we have this window open, we need to navigate to our grass folder and name this the same as it is in Max. I believe it's also case sensitive, so be careful. If done correctly, you should have an MTL in your main grass directory now. Finally, we can hit Export Nodes to create our grass demo clump CGF and the second grass demo clumps flowers CGF. Remember that it creates them separate because we checked Export File Per Node. If we hadn't, it would merge everything in the export list as one CGF file. Alright, now for the fun part. Let's hop over to our test level and go over to the Terrain tab and select Vegetation. Next, right-click and choose New Category. Name it Grass, and then right-click the category and select Add Objects. Navigate to the directory that you just exported to and select your two CGF files. Then we can increase the brush radius and select the Paint Objects button and start painting the grass geo onto the terrain. We only really need a patch like this to start dialing in the terrain material, so once you paint it, press M to bring up the Material Editor, and then type in the name of your material and the filter to locate it. Expand the folder and then select the material so that you can modify it on the right side. I'm going to delete my painted grass and turn on random rotation and align to terrain so that the grass has more variation as I tweak the material. Now I can position the Material Editor back on the screen so that I see some of the parameters and the geometry at the same time. The first thing we will change is the shader type from Illume to Vegetation. By changing this, we now have access to some cool shader options that help make the vegetation light more realistically. Next, to enable our transparency, we can just drag this alpha test slider to the right. The further you drag the alpha test threshold, the thinner the grass will appear. I'll leave it close to 50 for now. Next, let's turn on two-sided under our advanced menu so that the material reads from both sides of the geometry, which will create a much fuller looking grass. Then I'll expand the shader generation params menu and turn on leaves. Notice the lighting is much more even, which comes in very handy anytime you have crisscrossing alpha planes. The reason we use the leaves option instead of grass is because we want to load our normal map for better shading. The grass option doesn't support a normal map, which is less expensive from a rendering standpoint, so if you're having performance problems, you might try the grass option instead. Let's go up and load our normal map. Initially, it doesn't look much different, but that's because our spec color is still set to black. Remember, a normal map without any spec information will hardly ever show up. I'll check the spec color box and increase it so that it's a dark gray rather than black. I can also tint my grass using the diffuse color to try and match the terrain a bit more closely. You can also play around with the glossiness slider if you want your grass to have a nice sheen to it. As I mentioned earlier, my frame rate is taking a hit because I linked all the grass planes to a single dummy node rather than just attaching them together as one mesh. Let's take a look at a few more vegetation options that you might want to set. First, scroll down to the Cast Shadow Min spec and change this to medium. Having the grass cast shadows really adds some nice definition to the clumps. Then let's go over to this bending option here and type in something like 10. Notice how it automatically adds some procedural noise animation that resembles wind. This seems like a decent amount, but you might as well amp it up to see what's possible. Also, remember you can paint with a single object from a category as well, so you can add splashes of color by painting with the grass, clump, flower CGF here and there. One thing that can really affect a game's performance is the amount of draw calls on screen. Every time the game engine looks up a new material, another draw call is added to the scene. For instance, if we had a vegetation category with grass, flowers, rocks, ivy, and wheat, each referencing its own material, it would result in 5 draw calls for every cluster that we painted. It would be much better if we consolidated objects that use a similar shader type and export them all together using one material. We can toggle our perf data back on to see how many draw calls the current scene is making if you're curious. To demonstrate this, I'm going to consolidate some of the other ground cover we created for celery land into our current material. Here, I'm going to resize my grass and flower so they are 50% of the original size and move them up to the corner. This texture is a 2048, which will give us plenty of space for all these additional ground cover plants. When consolidating materials like this, it'll really help if you group your textures first, and then just drag over the group folder into the main document. With these groups selected, you can use Ctrl-T on the folder to move, scale, and rotate every texture within the group. This is obviously very important since you'll need the diffuse, normal, spec, and opacity to stay in the same position in rotation. Okay, now I've added a few more items to this texture, so I'll turn on all the opacity masks, and with the new layer at the top, I'll hit Ctrl-Alt-Shift-E to create a flattened copy of everything that's visible. Then I'll copy this into the alpha channel. Next, I'll turn on the corresponding layers and I'll save out my diffuse and normal map again. After consolidating these textures, I'll need to go back into Max and import the corresponding geometry and then update the UVs. Now, since everything references the same material, I can mix and match all these ground cover models as much as I want. I'll use these little ivy clusters to help disguise the grass planes when the player looks down. I can also make a bent grass plane and supplement by adding a few subdivisions and bending it with an FFD. I can even add a few lone blades of grass here and there to give it a little dimension from the side. Trying to problem solve and figure out ways to disguise the alpha plane geometry is one of the things I really enjoy about environment creation. Now I'll re-export the grass clumps and paint a new test area in the map. With the grass selected, I'll also change the max view distant ratio here to 0.3 so that the geometry fades at a reasonable distance. I'll do a final run through in game mode to check and make sure everything looks good up close. Notice how much more wild and natural it looks with the addition of some of those other ground cover plants. Also, the performance is much better than before. Now I'll spend a few minutes dressing up this area with some trees and rocks that we created for celery land. I'll add them as a vegetation category and objects the same way we did with the grass, so nothing new here. Once you've completed a few basic assets, the overall scene will really start coming together quickly. Alright, that wraps up our grass, ground cover, and vegetation tutorial. Be sure to check out the tree tutorial if you'd like to learn how to create this majestic oak. Thanks for watching. Goodbye.